Here are two more examples of radical expressions that we want to simplify. So we are looking for one of these perfect square numbers, and if there are several of them, we're going to look for the largest one. We're looking for the largest perfect square number that's a factor of 180. Well, I know that 9 is a factor of 180, right? 9 would go into 180 20 times. 9 goes into 18 2 times, 0 20 times. But when I look at 20, 4 is a factor of 20. So that would lend me to think about testing to see if 180 was divisible by 36, since 4 and 9 were both factors of 180. So I can always take my handy-dandy calculator. That's the easiest way to check. I can take 180, divide it by 36. I get an answer of 5. So yes, 36 is a factor of 180, and 5 is a prime number. So that is a good signal to me that I've simplified that as much as possible. 36 times 5. None of these numbers remain a factor of 5. And so the square root of 36 is 6. And the simplified radical form of the square root of 180 is 6 times the square root of 5. Let's simplify the square root of 192. So again, I'm going to check numbers, and I'm going to check at least up to halfway of the size of that number. So I want to check less than 100. 81 would be the highest number I would check, and then the ones below that. So I could try 81. That doesn't work. I could try 64, 192 divided by 64 gives me 3. And 3 is a prime number. That's a good clue to me that I've been successful and I've found the largest perfect square factor of 192. So sometimes you might want to start at the larger numbers and work your way down rather than smaller numbers and work your way up in your list of perfect squares. So 64 times 3 makes 192. Again, 3 is prime, giving me a good signal that I've found the largest perfect square factor of 192. The square root of 64 is 8. And 8 times the square root of 3 is the simplified radical version of the square root of 192.